All right, so the first conic section that we're going to do is circle, and which is the easiest, and I love circles the most out of all the conic sections. So first we will understand the properties of a circle, and secondly we will derive the equation of a circle in coordinate plane. All right, so you guys all know what a circle looks like. Um, let's draw a circle. Okay. Not the blue one. Let's take this. So this is how a circle looks like. And we all know that a circle has a fixed point called center, right? This is the center of the circle. And actually, if you think about circle is nothing but collection of all the points. See, it is collection of all the points which are equidistant from one fixed point. I hope it makes sense. If you see all these points, if you see all these points on the boundary of the circle, all of these points are equidistant from this center, right? This is actually the definition of circle. We also call, so this collection of all the points which are equidistant from the center, this is actually called locus. Locus is actually a collection of, so all the points which follow a fixed property to give you a curve, circular thing, not circular thing, but a curve. They give you a curve, and all there are some points which follow a fixed property, and they give you a curve. So here, all these red points, if you see all these red points, take any point on the boundary of this circle. All these points are actually at a same distance, from the center, right? We all know this. So a circle is a locus of all the points which are equidistant from a fixed point. And now this distance, we all know that this distance is called the radius, right? And this fixed point, this blue colored fixed point, this is called the center of the circle. Right? So if you have these two things with you, if you know the radius of the circle, and if you know the center of the circle, then a circle becomes fixed. These two things are the only things that define a circle. Okay. Now, see, every figure, every small thing, even a point, a line, and a complex number, everything can be represented on coordinate plane. So far we have done that. We can represent a point. See, we can represent a point on coordinate plane. We can represent a line. A point has coordinates x, y. We can plot a point on coordinate plane. A line is in the form of y equals mx plus b, right? So a line can be defined. A line can be fixed if you know its slope and the y-intercept. Then a complex number which is in the form of z equals a plus iota times b. You can plot a complex number on coordinate plane. We have just seen that. Now, even a circle can be plotted on coordinate plane. So this is what we're going to do now.